Hello and welcome to part two of the General Psychology lecture on Judgmental Heuristics. I'm picking up where I left off in part one. In part one, as you recall, I introduced you to three very commonly used judgmental heuristics: the availability heuristic, the representativeness heuristic, and the numerosity heuristic. And then I briefly answered at the end of that lecture why we use them. If they're not perfect, then the answer is that they're useful. And the other answer is that they're automatic. And you will learn later in the course that one of the many features of automatic thinking that sometimes it happens whether you like it or not. We don't have complete control over automatic thinking. But what I'd like to do with you in this lecture is to talk just briefly about two other issues, and these are a bit more controversial. Everybody agrees that we use judgmental heuristics sometimes. There's a bit more disagreement about how good we are at correcting our erroneous judgments or at knowing exactly how much we really know. But I'm going to take a pretty traditional view of that, which is that we're not great at correcting. We're certainly not perfect at correcting, and we err in a certain direction a lot of the time when it comes to knowing how much we know. So let's move on here. At least let's try to get my computer to cooperate. Yeah. Big question two. How well do we correct our mistaken judgment? So if a person tells you, no, that answer is incorrect, sort of like I did with the paper folding problem, and ask you to make an adjustment, the research that's been done now for more than 45 years shows pretty clearly that there's a basic bias to stick too close to our initial answers. In my field of social psychology, people often call that conservatism. It goes by a lot of different names, but the basic idea is that once you get an idea in your head, you stick too close to that idea, that anchor, that initial guess when you adjust your inferences. So that's the anchor. Some people even call that the anchor and adjust heuristic, but certainly people recognize that sometimes once you get a number or an idea in your head, it can be difficult to get it out. A cousin of this idea that you might want to read more about is the status quo bias. Once something happens, people have a hard time letting go of it. So a quick example I didn't mean to give you, we still produce billions of pennies in America every year. The US Mint makes pennies, even though pennies are basically worthless. So when a penny existed in the early 1900s, you could use two of them to mail a stamp, to buy a stamp and mail a letter. So a penny in the year 1910 or 1920 was almost like a quarter now, at least for certain purchases. So at that point, pennies were very useful. But with tremendous amounts of inflation over the past century or so, the pennies have become basically worthless, and yet we still make them. So that at least is a cousin of the idea that once you have something in your head, it's pretty hard to get rid of it. Okay, so the basic idea behind the anchor and adjust heuristic is that judgmental adjustment, correction, is typically insufficient. We're not that great at it. We don't do it as fervently, as extremely as we ought to. And a great example of that, excuse me, is the paper folding problem. This was also studied many decades ago by Kahneman and Tversky back in Israel, and they were both professors in Israel. They looked at a group of high school students and gave some of them what I call group one, the factorial problem you see in the top there. This list here, 1 times 2, and so forth, up to times 8. For a completely different group of students, they gave them this this logically identical but much different problem, in that it started with 8 and worked its way down to 1. So I think if you think about what this heuristic means, you get an idea in your head and you have difficulty letting go of it, you can imagine that they gave these students, I think, 5 seconds to quickly estimate. It's not a math problem, it's an estimation problem. They gave these students 5 seconds to make their estimations, and my guess is the first group very quickly said, okay, 1 times 2, then times 2, that's 6, that's 24, 2,840. And the second group said, okay, we got 8 times 7, that's 56, that's 336. I think that's 1680, but not at a time, 8,000. So the first group made a couple of quick calculations and gave a relatively low estimate to the answer to the problem. The second group also only had time to make a couple of quick calculations, maybe two, maybe three, maybe some very quick arithmetic, that's a word. Maybe some people who are really quick at arithmetic made it to four calculations, but practically nobody made it through. So the idea that if you anchor on a low value up here and you anchor on a higher value here, you'll give lower guesses here than you did here. And that's exactly what Kahneman and Tversky found. Okay. The students gave much bigger answers in the second group, group 8, than in the first group, group 1. The students in general also tended to underestimate the answer. They stuck way too close to the starting point of 0. The correct answer, by the way, I'm pretty sure I remember, is 40,320. So the answer is bigger than most people realize by just glancing at it. A little bit like the paper folding problem that way. All right. Here's another example of that I'll share with you, and it's from one of my favorite studies of the anchor and the just heuristic, because the person who did the study, George Quattrone, back in the early 1980s at Stanford University, had a very clever comeback to people who criticized the study. Let's first begin with the study, and I'll let young Brett, who wasn't out in the sun all day, give you a description of the study. Well, younger. George Quattrone, as you know, if you've read your executive summary on this lecture, did a very simple, very clever study of anchoring and adjustment by asking students at Stanford, and of course Stanford is right next door to San Francisco, California, so he asked students at Stanford if they thought the average yearly temperature in San Francisco was above or below 48 degrees in one condition, and he asked them if that temperature was above or below 82 degrees in the other condition. Now, students knew that San Francisco was a cool but stable place where it never gets super cold or super hot. And so those who were asked about 48 degrees all said, well, of course it's warmer than that. And those who were asked about 82 degrees all said it's colder than that. But the important result was those who were anchored on 48 degrees gave lower guesses about the actual average temperature of San Francisco than did those who were anchored on 82 degrees. And I forget already if I said this in your handout, but even if Quattrone gave people ridiculous anchors that could not possibly be useful or helpful, he still showed that effect. So if he asked some people if the average temperature in San Francisco was above or below minus 300 degrees, and another group whether it was above or below plus 555 degrees, which are both ridiculous, even those ridiculous anchors still bias people's judgments because they appeared to have stuck too close to those anchors. Now, I should mention that those ridiculous anchors did not make people say the average temperature in San Francisco is 300 degrees. People live there. They knew it wasn't the surface of Venus or the moon. But again, they stuck too close to their anchors, and that was true even when the anchors were ridiculous. And the reason he gave the ridiculous anchors, by the way, is that some people criticized his original study by saying that they thought, participants thought, that those were clues or hints. I'm telling you 48 because dudette, this person, it's cooler than you might think. And I'm telling you 82, which you'll know is wrong, and winking at you and making you think maybe it's warmer than you might have thought. So some people thought maybe the experimenter is being helpful by giving me an answer that's got to be somewhere near the right answer. So I'll say 60 in the 48 degree condition. So I'll say 70 in the 82 degree condition. That can't be exactly what was happening because even when the anchors were ridiculously low, minus 300, plus 555, that's about the temperature of a pizza oven, by the way, people still were about 10 degrees apart in the low anchor condition and the high anchor condition. So in the low anchor condition, they said about 60. In the high anchor, they said about 70 with a 10-degree gap. All right, let's keep moving here. That was question 2. Question 3 is a distant cousin of that question. How well do we know what we know? How aware are we of the limitations in our own thinking? And for a long time, at least, there's a bit more debate about this now. The consensus view is that we don't know that well what we know. But before I try to make that point a bit, let me give you an activity. And I mentioned the last slide that you had a reading, but I actually cut that reading. So you don't have a reading. You don't have an executive summary. I tried to cut back on your readings a little. And since you haven't read this, I can pick any of these. Let me pick my favorite, which is the gestation period, the pregnancy window of an Asian elephant in days. So I would like you to make a guess. Now, if you work at the zoo or you have a degree in comparative biology, you might know, but most of you probably don't know. What is the gestation period, the pregnancy window of an Asian elephant in days? And I want you to give your answer so that you are 90% sure that you've included the correct answer. If you want to, you can guess those others as well, but let's focus on the Asian elephant and make a guess. Give me a low-end guess and a high-end guess so that you're 90% sure that you've included the correct answer. Just to be ridiculous about the instructions, if I said you have to be 100% sure, you might say, well, okay, I'm going to go between a day and 43 years. Elephants only live about 50 years. Obviously, they're not pregnant for 43 years ever. So you know it has a limit. The question is, what is the range of answers that you pick so that you're 90% sure that you've included the correct answer? And give your answer in days, by the way. All right, I said I was just going to pick the one, but I can't resist picking one more. Let me also get you to guess the length of the Nile River in miles so that you're 90% sure that you've included the correct answer there. What's the lowest it might be? What's the highest it might be to be 90% sure that your range has included the right answer? So write each of those down. We'll skip the jumbo jet in the interest of time. Then I will show you the correct answers. Let me give you 15 more seconds. Low answer, high answer. I did rush you a little bit, so I apologize. When I did a survey much like this one decades ago in grad school, at the request of a person who's studying the bias we'll talk about here, he gave us all the time we wanted. It was a room full of people. We had 10 questions, not 3, and we had plenty of time to do it. And I will tell you that my answers in that situation resembled the answers of most of my students. And he argued based on that demonstration to us, a group of people who were either had their PhDs or about to get their PhDs in psychology, that we showed a bias. And to see the bias, let's see the correct answers. The correct answers are 4,187 miles. The Nile River is the world's longest river. I'm pretty sure it's even longer than the Amazon. Way longer than the Mississippi, which is a very long river. And the most tricky question to most people, the gestation period of an Asian elephant is not that far short, just a couple of months short of 2 years. They're pregnant for a very long time. Now they make 180-pound babies, so maybe if you thought about that, you might have thought it would take longer. But if you know that many other mammals are not pregnant nearly as long as people are, you might have said 8 or 9 months at the very, very most. But the correct answer is 645. Unless you've lived in Egypt or been to the Nile River a few times and you remember that, most people think it's 2,000, maybe 3,000 miles. Very few people realize how long it really is. So the point of this demonstration is that virtually everybody who answers these 3 questions misses at least one of them, and many people miss all 3 of them. Now, if you're really 90% sure, you should get at least 2 of them, probably all 3 of them correct, but very, very few people do that. Now, that's a demonstration of the overconfidence effect. People also call it hyper precision. You don't need to worry about that label. Let's just focus on overconfidence. And if you want a definition, here it is. Overconfidence is a very simple definition. It's simply the tendency to be more confident than correct. And one example I just gave you was providing overly narrow confidence intervals. A second example that I've been guilty of many times is thinking I'll finish a job way before I finish it. It doesn't matter whether it's an art project or building a shed or solving a problem or giving a lecture a lot of the time. I often think I will finish something way before I actually do. That is an example of overconfidence. I forget what Homer said here. Let's listen to Homer.
Absolutely, positively.
Oh, I'm sorry. That was Flanders saying he's absolutely sure of the correct answer when, of course, he isn't, because very often we think we know the answer to a question, but we don't. Now, there is controversy about this effect and just how pervasive it is, but some of the ways that I think are the most straightforward ways to measure it, like here's a job you know you're going to do. Tell me when you'll be done. That particular version is called the planning fallacy. That is a very robust effect. If you ask a bunch of people if they think they're above average or below average drivers, 80, 85, sometimes 90% of people say they're above average at driving. So this bias and many of its cousins, like the above average effect, is a pretty robust bias. Hyper precision, which I just showed you, that one's a bit more controversial, but I think it's pretty safe to say that human beings are overconfident more often than they're underconfident. And if I can poke fun of myself a little bit, I rarely do. I more often brag and talk about how awesome something I've done.
Excellent.
In the summer of 2014, so exactly 6 years ago now, I think it was in July, I thought I could go from building that quick bottom, that's green lumber you use to build something that's going to be exposed to the weather, but I could go from that to a finished 6 foot by 8 foot shed. I think I made the shed in less than a week. Now, I should mention quickly, I used to work as a framer. I did it one summer, done carpentry my whole life, so I know carpentry and framing pretty well. I mean, I didn't do it as a long-term career, but I know how to frame. I knew I could do it. I had some instructions. I followed them pretty carefully. I adapted them, but I had really clear instructions, I should say. I thought I could build a shed in about a week. I thought, it would be less than a week because my brother Barry, who worked as a framer for 2.5 years, this guy is really a carpenter. He's really a framer. With him helping me, I'll be done in 4 or 5 days tops. As it turns out, it took me something more like 2 weeks because I hadn't done any framing in a while. I forgot to go from the foundation to this, what you see here, which is still not done. It's been primed, but it's not been painted. It's still not done. That took me something like 2 weeks, with Barry helping me 4 or 5 of those days. And there are 2 or 3 reasons why I was overconfident. First of all, I hadn't done this work in a while. I'd forgotten that it's a lot of work. There are a lot of steps. You run out of nails. You run out of screws. The door didn't quite fit. You have to make an adjustment. You have to put in a shim. And on top of that, because Barry helped me, he talked me into making it much better than I would have on my own, with all these double headers and all these layers of extra wood to strengthen it, make it super strong. It's a hurricane force shed. Well, that meant I had to go get some additional wood. That meant that it took extra steps. And on top of that, I didn't take into account the fact that it rained a lot that week. I didn't check the weather in advance. I should have known that in the summer, it often rains, and the shed wasn't completely done until about 3 weeks later. And when it was done then, I paid a group of painters who were painting my neighbor's house to paint it brown instead of leaving it primed and not quite finished. So in a sense, I never finished, but even with help from painters, it took me about 3 weeks. So things often take longer than you think. That's overconfidence. Well, if we're so overconfident, if we use these heuristics, if we engage in anchoring and adjustment and do these things all the time, if we're so dumb, how do we put a man on the moon? That's a quotation from a critic of research on judgment and decision making. We did put a man on the moon. We've done a lot of amazing things. Some of us invented smartphones. I didn't. And my answer to that critique is there's a sense in which you're right. People are capable of very sophisticated thinking, but that's when we sit down in front of a computer with a team of people checking our work, and we compare our notes and go through it step by step. In day-to-day life, we very often use these heuristics because they work pretty well. And of course, this critic is right. The fact that we're imperfect does not mean that we're completely ridiculous at everything. So I'm going to give you, to close up this short lecture, a couple of examples of when heuristics work quite beautifully, so they're not always problematic. I'm going to show you that you can use a heuristic to very quickly answer two different questions. Are there more words in the English language that start with, you have four judgments, S or Z, K or E, A or N, and M or T. In each case, your job is to say which of those letters is the beginning to more words in English. Notice I said it's not just frequency, it's word beginnings we're talking about here. So I hope the first one's really easy. S or Z. Are there more words in English that start with S or Z? Not a trick question. And of course, the answer 95% of students. Be patient with me and do one other. Well, let me pause that. You don't want to hear from younger me, you want to hear from old me. Yeah, the answer is S. K or E, practically everybody says it's definitely E. E is a very common letter. K is a very rare letter. Lots of words start with E, not many words start with K. People get that one right. People have more difficulty here, but I'm going to say about 80% of people, maybe you're one of them, gets this question correct. And the answer is, yeah, you're right, it's A. It's A. And then this is the most difficult one of all. Still, something like 75% of people get this one correct, and about 2/3 of people get all four of these correct. So M or T, are there more words in English that begin with M, R, or are there more words that begin with T? And the majority of people correctly say yes, it's T. And it is, but just barely. It's not a very big margin at all. But using the availability heuristic, most people come to that correct conclusion. Okay, this one's even easier, I hope. If I ask you to identify the most frequent, most common, and the least frequent, least common name from this group of four male first names, everybody, even people who are immigrants that have only lived here, let's say a year or less, pretty quickly recognize that James is a very common name. You can't live in the US for a year or more, not bump into lots of people who are named James. You can't read a story without a person named James in it. So James is a very common name. There have been periods when it was the most common name in America, American men. It's not the case now, but it's still very common. And of course, people also recognize that's the most common name. People also recognize quite quickly that the word justice, spelled with an S, not even a C, is a very, very rare first name. There was a very good college basketball player who I think was drafted into the NBA who had this as his first name. He's the only person I've ever heard of with justice as his first name. That's extremely rare. And Ken and Brent are somewhere in the middle, very common, but not nearly as common as James. So notice what you did here is you used the availability heuristic. I can think of dozens of people I've met, read about named James. I've heard of nobody, or maybe one person named Justice. I've bumped into a few people named Brent, quite a few people named Ken. You can pretty quickly estimate the frequency of those names by just consulting your memory, by just using the availability heuristic. So we use these heuristics because most of the time they work pretty darn well. Okay, general conclusions, I should say, I think. One conclusion, human judgment is imperfect but adaptive. The world would be a more difficult place, not a better place, if we didn't have judgmental heuristics. They're quick and dirty rules of thumb for making snap judgments that we often have to make under great time pressure. And again, these heuristics can get us into trouble. We might be in even more trouble if we didn't have them because we'd be overwhelmed by breaking out our calculators and trying to give the complicated mathematical or actuarial answer to important day-to-day questions. All right, that's it for the conclusions. That's it for the additional details of judgmental heuristics. And I hope you enjoyed this lecture and it made you think about how often, probably for pretty good reason, you use judgmental heuristics. I don't think there's a day that goes by that we don't use judgmental heuristics many different times. That's both good and bad. All right, thank you and talk to you again soon.